All we're asked to find are the x coordinates of the stationary points here, the x coordinates only, so that makes it nice and easy. Now remember, when you've got that absolute value of x, we can look at it in two cases. We can say, well, when x is positive, let's look at when x is positive, and let's look at when x is negative. We can see from here that when x is 0, we get y equals 0. That's all nice and fine. Anyway, so of course when x is 0, we don't need those absolute values either. So you could say when x is greater or equal to 0. There we go. All right, but really most of the time we're just kind of looking at two cases, positives and negatives, and seeing, you know, what happens. Then we don't have to use the absolute values. So if it's positive, then it would just go by this function here. Whereas if it's negative and I need the absolute value, then I times the negative by a negative. So I have negative x, and then I don't need to use an absolute value, but that of course is the same as just e to the x there. All right, so let's differentiate, because that's how we find stationary points, when you make the first derivative equal to 0. So here you've got a product rule, so there's 1, 2 functions of x. So differentiate the first, you get 1 times the second, plus differentiate the second, in this case minus e to the minus x, times the first. All right, let's do the same here. Differentiate the first, which is 1, so e to the x, plus differentiate the second, which is e to the x, times x. All right, and you can see for both of those, well, this one I can factorize by e to the x, e to the minus x. This one I can factorize by e to the x. And I'm looking for where y dash equals 0 for stationary points. Yeah, y dash equals 0. So you can see here that x would have to be 1. We know the exponential won't give us a solution, but in this one, x would be negative 1. So there's going to be two answers depending on whether x is positive or x is negative.